Hello and welcome everyone to today's webinar on how to seamlessly leverage Anaconda on OCI. My name is Terry Van Cleve and I'm a Marketing Event Manager for the Developer Initiative here at Oracle. We're excited to show you the unique benefits of the Anaconda repository and how you'll benefit from the Conda package manager for your project dependencies. If you do not currently have an Oracle Cloud account, we've got a special promotion in the chat as well that will allow you some extra credits. If you have any questions during the webinar, please ask them in the Slack channel and we'll answer them live after the presentation. The link to join is bit.ly/devrel on Slack. Once you're in, you'll land in the general channel, and from there you can search for Anaconda on OCI to reach our dedicated space for Q&A today. Today's webinar will be presented by JR Gauthier, Product Manager and Data Scientist for Oracle AI Services and Data Science, and Christian Capdeville, Director of Product Marketing at Anaconda. So without further ado, I will turn it over to JR.
Hey, thank you, Tara. All right, so as I'm sure many of you know, machine learning these days is driven by open source libraries. So on this slide, I just put a few of what I would consider some well-known libraries in the space, but this is just really a small sample. So the focus of my presentation today will be mostly on Python and the machine learning ecosystem. And the popularity of some of these open source packages is actually accelerating. So this is a nice little chart that shows the number of stars over time for some of the most, I would say, popular open source libraries in machine learning. And some of the most recent ones actually, and the one that I want to highlight is Hugging Face, which came out a few years ago. It's actually, its adoption is faster than any other open source package in machine learning at the same point in time in their history. So not only is open source popular for machine learning use cases, but the trend is actually accelerating. And we see this in enterprise organizations as well, and they are adopting open source more than ever. And it's not just on the consumption of open source software, it's also on the production side. So more and more organizations are actually empowering their employees to contribute to open source projects. In some cases, they will also fund those projects. So in the most recent Anaconda State of Data Science, I invite all of you to read. Actually, over 50% of the respondents to the survey said that their employers are giving them dedicated time to contribute to open source project. That's quite interesting. And for organizations that actually enable the use of open source internally for consumption, the IT department is typically the one that controls what open source tool can be used for what purpose. And it's the case in almost 90% of the cases. And just like any other software, so open source packages come with security challenges. As you may imagine, if you look at GitHub project, there's usually tens of or hundreds sometimes of contributors that are there to write the code, to maintain it, to evolve it. And so that comes with its own risks. So there's a supply chain issue. So you want to make sure that you're getting the right source code from a trusted third party, they're getting a software bomb, that you're scanning the vulnerabilities. But what's scary about it is that about a third of all these organizations, according to that survey, don't seem to be doing much or anything to really address those issues. So I think this is where the Anaconda can shine here. And in practice, you really never use only one or two open source library. A typical machine learning project would involve sometimes tens or hundreds of packages. So what you need is more than just a package manager. You also need an environment manager. And that's what Conda was built for. It's both a package and an environment manager. And this is an ideal tool really to isolate the dependencies that you have in your various machine learning project. And this brings me to the partnership that was announced earlier. So in August, Oracle and Anaconda announced a joint partnership that enables the use of secure software for enterprise users on OCI. So what does that mean in practice? Well, it means two things. It means that first, any OCI customer, including Oracle employees, can use the Conda package manager on OCI. And you can also use the Anaconda repository of packages to install binaries on your machine running on OCI. So previous to that, if you had a commercial use case, you were an OCI customer, you had to purchase a separate license from Anaconda to be able to use those tools. But under this partnership agreement, any and all OCI customer can now use Anaconda and the Conda package manager for commercial purposes without having to purchase a separate license. So now the question would be, well, why would you use Anaconda in the first place? So I'm going to let my colleague Christian actually share this share a little bit more about the Anaconda technology itself.
Thanks, JR. Appreciate it. Thanks, everybody, for joining. All right, so essentially just wanted to take this chance to kind of give an intro to Anaconda if you're not already familiar, why folks use us, and how we help data scientists and machine learning workflows. So number one question is why do practitioners choose Anaconda? Why do people use us? And the short answer there is, it saves time and makes life easier. So why wouldn't you want to? Anaconda distribution has become the standard for Python data science. Today, we have 30 million users. We served up 6 billion packages last year. We have 2.5 million people participating in our online community, Anaconda Nucleus. So we're really passionate about open source and what it enables people and organizations to accomplish. And for the past 10 years, we've been a fixture in the open source community, and we're looking to continue to grow that. Now, at the end of the day, really people use Anaconda because it saves time, makes life easy. And so how exactly? Well, one thing to think about with regards to Python, especially Python open source, is the dependency problem. So this is a look at the packages that are dependent on Python. And it's kind of messy, right? So it can be kind of hairy and complex to deal with all these dependencies, especially when you start talking about different versions, different platforms, etc., without breaking your environment. And this is what is affectionately known as dependency hell. So you have this kind of very complex web, and with that level of complexity also comes some fragility. So changing a single element in this web can break a lot of things if it's not handled properly. And ultimately, as data scientists, as analysts, we really just want our environment to work so that we can do our work. So enter Conda. As JR mentioned, it's a package and environment manager in one. It can be used with any programming language or even multi-language projects. Helps you with your dependency management problems, and it handles environments natively, so you don't need any separate environment management steps. I wanted to give a quick look at what that might look like. So you have environment A, B, and C here, which can be using different versions of Python, different versions of different open source projects. As JR mentioned, you usually are not using just one library, you have several. And for various reasons, you might have different versions, you might be using different platforms. And the ability to segregate these environments and to work across multiple languages helps to enable reproducibility, collaboration, scaling, and can be used for various projects, teams, and other use cases. So this invariably brings about a question, okay, this sounds great, but what about pip? So Conda versus pip, which is better? And of course, that's a little bit of a clickbait question because ultimately Conda and pip serve different purposes. And they directly compete in a small set of tasks, primarily, let's say this first one, where they both can do certain things. They can install Python packages in isolated environments. Where pip may be used to install Python packages specifically in any environment, Conda is really more about installing any package within a Conda environment. And whereas pip may manage Python packages within your existing system installation, Conda can be used to manage Python packages that rely on external dependencies like NumPy and SciPy, etc. Also, there's some differences in how they solve for dependencies, which I'll talk about in a second. I wanted to include this little cheat sheet that shows some of the various differences across a few different dimensions. The pip, installs Python software packages, wheels, or source distributions, which can require that systems have compatible compilers and possibly libraries installed before invoking pip. Conda packages are binary, so there's never need to have compilers available to install them. And Conda packages, as we mentioned, are not limited to Python software, so they can contain C or R packages, any other software. And the big thing on dependency management, when installing packages, pip will install dependencies in this recursive serial loop. So there's not really an effort made to ensure that the dependencies of all those packages are fulfilled at the same time. So this can lead to environments that are broken in subtle ways, and you might have experienced this yourself, especially if you're mixing Conda and pip. If packages that are installed earlier in the order have incompatible dependency versions relative to packages that are installed later. And actually, I'm going to take this opportunity right now to put out a poll for everybody here. let me launch it here. Essentially, it's just a simple question. Do you typically use pip or conda or both? And we'll see how folks normally enact these in their workflow. So I talked about pip and how it solves for dependencies. Well, how does conda do it? Well, conda uses a satisfiability solver to verify that all the requirements of all the packages installed in a certain environment are met. So this check helps prevent the creation of broken environments. And as long as package metadata about the dependencies is correct, Conda will predictably produce working environments, which is our ultimate goal, right? And so I wanted to give also a quick look at the package build process. Anaconda, we rebuild our packages from source on our private infrastructure. There's a few reasons for that. One of them is it helps us to make sure that everything just works together. And another one, which feeds into Anaconda being used at organizations, being able to make it secure, scalable, trusted, all that kind of stuff. And so starting at the top there, we have this kind of update and patch or fix the packages, going through to validating vulnerability information, testing to make sure everything works together, all the way through to distribution. And this is a second look that kind of breaks it out a little bit more so you can see each step. Essentially, going from the top where we're making sure that the packages are compiled to be cross-platform, cross-language compatible, down through vulnerability data that we attach, which can be used to in our security tooling for enterprises. And then we also do a lot of testing to make sure that that cross-platform, cross-language compatibility is intact, and we have fidelity to the upstream project. All the way through making sure that we manually review the packages and that it's ready to go for distribution. Looks like we got most responses in the poll here. We have most folks doing both. Thanks for sharing on that. So that's how it works for individual users, and that's why individual users will use our packages. But there's a second part of the story, which is essentially organizations. So why do organizations choose to use Anaconda? Well, essentially, we're seeing that more and more organizations are using Anaconda packages. They're bringing in Python open source to their data science and machine learning workflows more every single year. Of course, there's a lot of reasons for that. This audience is probably well versed in the fact that it provides a ton of flexibility. It ensures that you can basically innovate faster. You don't have to rebuild everything from scratch. And pretty much every IT organization and all sorts of applications have some degree of open source software. So for organizations doing this, though, there is a risk, especially if you're using community repositories like pip. So I wanted to give a little example of one such risk, which is dependency confusion. There was a very interesting article that you may have seen from Alex Pearson, who discovered that there is a potential for people who are using both internal and external software and who have their libraries out there on GitHub to be able to find vulnerabilities, or rather, I should say a chink in the armor where somebody can inject a malicious package, make its way into a company, and then use that package to gain access to sensitive information. So the question he essentially asked was, what happens if malicious code is uploaded to public repositories under the same names as found in those companies' internal repositories? Because pip might go and grab from the public repository first rather than going internally first. And so here's what he did. He found a package name, and he went and realized that it was not on PyPI. So he went and put it on PyPI with a updated version number. And so it works like this. An individual is running up a project. He's going to get a package, and there are a few different dependencies for that package. We'll call them alpha and beta. And these are all the versions. Now, alpha is the internal source, kind of the internal project that is not available on PyPI. So the attacker goes and puts a new version of alpha on PyPI. It's called version 66. And this effectively makes its way into the organization, is pulled in as a dependency. And the malicious software is then able to grab sensitive information and send it out through to an external server, to an external PC. And he did this specific example. He did this with PayPal, Shopify, a lot of the biggest software companies. So this is a very real threat when you're using community-based software. It's one of the advantages of using something like Anaconda. where if you have these dependency confusion or typo squatting attacks where people can just upload any package they want to a public repository, being able to use Anaconda means that you eliminate those attack surfaces entirely, because we build those packages from scratch on our private infrastructure, so that it's not completely open to anybody to just drop a package in there. This can help, especially when you're talking about enterprise IT and security concerns. We want to make life easier for the end user, not just outside of the organization, but also inside the organization. And what this might mean for y'all is that we want to get IT off your back and still let you use your open source packages that you need to just get your job done. Appreciate everybody listening to that segment and for the participation in the poll. I'm going to pass it back to JR to talk about how this looks inside OCI.
Thank you, Christian. So what I'm going to do next is I'm going to show you a little walkthrough demo of how you can use Anaconda and OCI. And probably the easiest way to do it would be initially through the data science service running on OCI. So let me just walk you through that process. So what I'm going to show you is how you can install the conda environment that was pre-built, how you can create one from scratch, and how you can share a conda environment that you've created with your colleagues. So first of all, let me just go into the hamburger menu here on the top left corner. I'm going to go under Analytics and AI, and I'm going to pick the data science service. Let's take a second here. So I've already created a project. You can create one if you want. I called mine Anaconda webinar, so I'm just going to jump into it. The first step will be to create a notebook session. So we're going to use DripToLab initially here. Creating a notebook session, in this case, you can use standard options here for compute shape. I would advise that maybe you pick a shape that has a couple of OCPUs at least. Doesn't matter which one it is. And then all the default options are good for this, this demo here. So default storage, make sure you have egress to the public internet if you want to reproduce the steps that I'm going to show you today, just because we're going to be pulling some packages from Anaconda. And then runtime configuration, again, this is optional, but you could in principle clone our Git repo samples because it contains some information about how to use conda environments and things like that. But this is optional, you don't have to do that. You can click on create, takes a couple of minutes. I already created one before the call. So we're going to jump into it. And we're going to take a look at conda environments in here. So when you first launch a notebook session, you'll notice that it comes with two kernels. Let's just take a look here. So it comes with two kernels here. So there's a Python 3 and a base root environment here. And both of them actually are pretty empty. So if I were to just run a conda list, so conda actually comes pre-installed in a notebook session. But if I just do a conda list on these environments, you'll see that there isn't much that you would want to use perhaps for a machine learning project. So let's just take a look here. So the file will show up here, and then we can open it. So what you see here is a list of, first of all, the packages, their version, the build, the hash here, and the channel where it's coming from. So we're in the process of migrating all of our packages from CondaForge to Anaconda, following that announcement with the partnership announcement in August. So we are rebuilding all of our environments to use Anaconda. But so what you see here is that actually quite a few are coming from CondaForge, some of them are coming from pip, but they're pretty bare bones. So there's Python installed in this here, so 3.8.12. But if you were to look at, I don't know, is there scikit-learn, is there XGBoost, is there, TensorFlow? So none of these packages would be found. So it's a pretty small environment. So you really have two options at this point. You can either install the conda environment or create one from scratch. So I'm going to show you the first flow to install the conda environment, the pre-built conda environment. So the first step would be to go to the Environment Explorer. And here, what we have is a list of pre-built environments that you can install in your notebook environment. So there's 45 of them, tackle a variety of use cases, or some of them are focused on specific frameworks. So we have some for PyTorch, TensorFlow, some for PySpark. So all the major libraries are covered. You can filter on CPUs here or GPUs, depending on the shape that you're running your notebook session in. Those conda environments, by the way, are reusable across the service. So you can use an environment in a notebook session and then use it for launching a job or maybe for a model deployment, so you can use them across the board. So maybe the first step that I want to do is just install one of those. So I can search for, let's say, if there's one for TensorFlow, and I have a one for TensorFlow here, 2.7 for CPU. So if I were to click on the caret here, I would have some information about that environment. All the conda environments in the service are version. So we sometimes update the dependencies of that conda environment. We sometimes fix vulnerabilities. And so we upgrade the version environment number that way. So you see here, there's one that's already version 2. So to install the conda, in the service, we highly recommend that you use our ODSC CLI. So ODSC is a toolkit that lets you manage the lifecycle of those conda environments. There's a few reasons why you want to use ODSC versus using the conda CLI. The reason why is because if you're using ODSC, especially to create custom conda environments, which I'll show you in a minute, we also add additional packages into the installation to make sure that your conda environment is compatible with JupyterLab so that it shows up as a kernel. But in this case, let's just suppose that I want to use this conda environment. I can simply copy the command, and then I'll be able to install it in a terminal window. So just paste it here, and then I'll install the conda environment. It's going to take maybe a minute or so to install it, and then you'll see it as a separate kernel in the launcher window in a minute. So the underlying technology here is we're wrapping around Conda, the package manager. We're also wrapping around the Conda Pack toolkit. So Conda Pack is a toolkit that archives Conda environments, so create tarballs out of them, and then it allows you to ship them between different machines. So all of those pre-built Conda environments that you can install are actually sitting in an object storage bucket in data science service tenancy. So we pull those environments and we use the Conda Pack to unzip them and make them available in the environment here. So this is done already. So let's take a look. If I look back in my Environment Explorer, I refresh here, I should see it under the installed category. So I have my TensorFlow 2.7 environment here installed. I can take a look in my launcher window. Sometimes it takes a minute or two to see the kernel. So, okay, right, great. So it shows up here. So from there, you can just simply create a notebook session or create a notebook actually, and it should run inside of that kernel here. So the TensorFlow 2.7 kernel, if you want to switch to a different one, you can always do it here from the menu. So that's a simple flow to actually install the Conda environment that was pre-built. The alternative would be to create one from scratch. And again, here, the ODSC CLI comes very handy. So I'm going to just clear this and maybe zoom in a little bit. So ODSC Conda gives you a very rich interface here. You can do several operations on Conda environments, and one of them is to create an environment. And you do it from a Conda compatible environment file. So I'm going to show you to do this quickly here. So there's really minimally, there's two parameters you want to specify. The first one is the channel or series of channel where you want those packages to be pulled from. So I'm just going to specify Anaconda. And then for the dependencies, I'm going to specify just two simple ones. So let's say I want to install the null version of Keras. Now, Keras is part of TensorFlow, as I'm sure most of you know. But let's say I want to install the new version. So what I'm saying here is I want those packages to be pulled from the Anaconda repository, and I'm going to install Keras and TensorFlow. And then I'm just going to use the ODSC conda create command. Let's take a look at what this thing takes. So it takes an environment file. So we're going to take this here actually, environment.yaml, and then it needs a name. So we're going to give a name. We'll call that Keras Slim as the name of my Conda environment, and then a version. So as I said before, all of our condas are versions, so you can select an initial version number. So we're going to call that 1.0. And so this process will take a few minutes. So in the background, we're using Conda to pull packages from that Anaconda repo. And we're also adding additional packages, as I said before, to the environment. So if I look at the actual YAML file that we will be using in the background, this is the one. So there's your dependencies that you've specified here. But we're also adding, as I said before, we're migrating everything to Anaconda from CondaForge. But so these are the additional packages that we're going to be installing in the Conda environment. So some of these are really useful to make sure that the Conda is compatible with Jupyter Lab. So this why you see some of these like IPY kernel and Conda kernels. And additionally, we add some packages coming from pip. So some of those are not available yet on Anaconda. So for that, you can also specify pip packages from PyPy, so OCI, the OCI CLI, and our client to connect to the database are available here. So this is what we're going to be installing in that Conda environment. So while this is ongoing, I wanted to show you another step in the process or in the life cycle of those Condas. So once you create a Conda, it's going to just show up here as an additional kernel. There's one additional use case you may want to contemplate here is the ability to share that Conda environment that I just created across notebook sessions, or maybe as with different parts of the service. So we call that publishing a Conda environment. In order to do that, you need to first go into the settings section of the notebook and specify an object storage bucket where the Conda environment is going to be published to. And so we typically recommend that you use a method of authentication resource principal where you authorize your notebook session to access that bucket. So there's two options you can use. You can use resource principal, or you can use, well, now it's called API key here, which is really user principal. So you need to provide an OCI config file and your private key. You need to upload that to your notebook session. And so the notebook session will use that in order to, or ODSC actually will use that to publish that bucket or to authorize, or to authenticate to object storage and push that Conda environment to object storage. So really what you need to do here is specify which bucket you want to use and the namespace of your tenancy. So if I go back to my console here, I'll go to the buckets object storage here, and I will select one of the buckets that I created for this. So I've created this bucket called Anaconda webinar bucket here. It's empty. And this is the namespace. So this is the name actually of my tenancy that I'm running the demo in. So I'm going to use that bucket as my destination for my Conda environment. So this is the big large, and then this is my Anaconda webinar bucket. So all of the environments that I will publish will be pushed to that bucket. I'll show you that in a minute. So I'm going to save these, and I'm going to exit this. So I'm going to go back to my terminal here and see where we are in the process of creating that custom environment. So we are almost done. So almost done here in a minute or so. We should see that new environment set up. So if I go to my Environment Explorer, I refresh this here. I see now 2 installed. So if I just eliminate those, so I see here we have the Keras Slim environment that was created a couple of minutes ago. Now, if I go to my launcher window, I should be able to see that new environment here. So I can launch a notebook, and hopefully, if I import Keras, it should work. That's great. So now, one thing we can do is we can take a look actually at the packages that were installed. So if I do a conda list, Keras packages, so just do the same trick again. Well, you should be able to take a look and see what was installed and from where. Right? Let's take a look. So again, here, let's find out what or where Keras is found. So Keras was actually installed, so it's version 2.4.3. I could have specified which version I wanted in my environment YAML file, but I just let that be unrestricted. So it pulled the package from Anaconda, and this is the build number. So I could go back to anaconda.org and find out, if this is the most recent package or if there's maybe a more recent one. Let's take a look at TensorFlow just for fun. So TensorFlow is also found from Anaconda here, version 2.4.1. So looks like it's doing the right thing. What we can do next is to, as I just said before, let's publish that environment. So if I go back again to my, let's just clear this and do ODSC conda, use the help and see what we have here. So we have the publish option. So I can do, actually, there's an even easier way to do this. I can just go back to the Environment Explorer. Under the install category here, I see that I have my caret slim environment, and I can click on the caret here. And there's actually a few commands that pop up here. One is to publish, one is to clone, one is to uninstall from my notebook session. So I can just simply copy and paste this command to publish an environment. So I'm going to copy this, go here, and then I'm going to just simply paste it and execute. So what it's going to do in the background is it's going to take the conda environment, as I said before, it's going to use the conda pack toolkit to zip it, tar it, zip it, and then it's going to push it to object storage in that bucket. So this is going to take a minute or so. It's usually relatively fast. This is a small environment as well, so it should be good. While this is ongoing, I wanted to, this is in progress, I wanted to show you a separate notebook session that I've been running. So if I go back to my data science project page, I open the same project. I actually have another notebook session running in the same project. So let's open that one. And what I'll do is I'll set up the bucket in my settings to be able to see environments that were published. And I'll be able to install that same caret slim environment into my new notebook session. So this is a notebook session that I've run before. So I'm going to go into the settings section. I've pre-filled the same values. So the tendency here, the bucket name, the same thing. And so we should be able to click on the Environment Explorer here and see what's available. Let's just refresh. So I see under the published category, there's one environment here. So this is the caret slim environment. Looks like it was created about a minute ago. So let's take a look at our notebook session here where we created this environment here. And it looks like the process of publishing the conda is done now. So just to confirm, I can double check my bucket. So go back to storage here and look at that Anaconda webinar bucket here. I see that I created a conda environments folder under CPU caret slim version 1, and here's my environment, 666 megabytes. So I can then take my new notebook session and just apply exactly the same operations. So I can decide to install that conda environment inside of my notebook session. I can modify it, publish a new version, and push it to the bucket, and someone else can pick it up and use it. So kind of gives you an overview of the flow of how you can leverage both conda, well, we wrap around conda and ODSC, but how you can use conda, how you can use conda pack and the Anaconda repository to safely pull binaries and use them into your machine learning project. So I hope I'm going to give you a flavor for the kinds of operations that you can do on conda environments in the data science service here on OCI.
All right, so if you enjoyed today's session, we'd like to invite you to join our upcoming developer events. And we also encourage you to share with us any feedback that you have on today's session and to reach out to us with any questions. If there are no more questions, I'd like to thank JR and Christian again for this wonderful presentation. And thank you all for joining us here today. And with that, I will go ahead and end the session. Thanks again so much, and we hope to see you again next time.